Today's goal is to use arithmetic operations. We know that means that we're going to add, subtract, multiply, maybe divide, to prove or disprove. Prove or disprove means you're showing something is either always true or it's not always true. Algebraic hypotheses, and by algebraic we mean not graphic. So probably expressions with variables. Okay, example 1. A student thinks she notices a pattern from the equations below. Prove whether or not, so maybe this is true, maybe this is not going to be true. The difference of the squares of consecutive integers is always odd. Okay, let's unpack that statement. The difference, meaning we're taking things and we're subtracting, of the squares, okay, we know that, exponent 2, of consecutive integers. Consecutive integers are numbers that are next to each other, like 2, 3, 4, or 17, 18, 19. Okay, let's look at the example above. Oh, we've got 1 and 2, 2 and 3, 3 and 4, 4 and 5. Okay, that's what they mean by consecutive, is always odd. Now, how would you know if it's odd? Well, terms that are even can always be written in the form 2m, right? It's always 2 times some number because even numbers are divisible by 2. Odd numbers would have been divisible by 2 except they have an extra. So they can be written in the form 2m plus 1. For example, 17 is 2 times 8 plus an extra. We have this plus 1 because they are not divisible by 2. That's what makes them odd. Okay, we want to prove whether the difference of the squares of consecutive integers. Well, consecutive integers would be like n and n plus 1. They're next to each other. It's the next one in line. And squares mean we're going to square them. Looking at this example, it looks like we'll put the bigger one first and then the smaller one. So we'll square the bigger number, n plus 1. We'll square the smaller number, n, and then difference, we're going to subtract the 2. And we want to know if our result is going to have the form 2m or 2m plus 1. Well, let's see what happens. N plus 1 squared means n plus 1 times n plus 1. Which we can use the box method to expand. My n squareds cancel out. You get 2n plus 1. It's an odd number because it's not divisible by 2. It would be divisible by 2 except for the extra number. So, oops, I don't need to box in this result. This entire thing is my proof. I did prove that indeed the difference, when you subtract consecutive integers, will always be odd. Let's take a look at the next one. The math wasn't the hard part, it was really the setup. Example 2, Mr. Lloyd wants to find a shortcut for his calculus students. That's nice of him. He believes that 2x minus 1 times the quantity x minus 2 squared is this expression. Is he right, correct, or confirm using his attempted proof below? Again, we don't know if he's right or not, so let's see if we can follow along in his proof. So he writes out the expression. Okay, what's happening in step 1? It looks like he's taking this x minus 2 squared, and he's writing it out. It means x minus 2 times x minus 2. Well, that makes sense. What's happening on step 2? Again, he's playing with this x minus 2 times x minus 2. You can use the box method if you like to confirm. That makes sense. Okay, so far, so good. In step 3, oh, wow. It looks like he's taking this entire expression and multiplying. I have no idea if that's right. Let me confirm on the bottom by doing a little bit of multiplication of my own. If you can look at it and know, good for you. I'm going to need to do the math myself. Let's do it carefully. We've got some like terms to combine. Let's see how we did. 2x cubed, yep, that's this term, plus 8x squared. Ooh, Mr. Lloyd, you're making a sign error here, my friend. Plus 8x minus x squared plus 4x minus 4. Wow, we had to dig through this entire proof to find one sign error. So no, Mr. Lloyd is not correct. It turns out that 2x minus 1 times x minus 2 squared is equal to 2x cubed, if we combine our like terms, minus 9x squared plus 12x minus 4, he made a sign error when he multiplied. Okay, last example of the day. The sum of the least and greatest of which three consecutive integers is 60. Write and solve an equation to find the numbers described. This is similar to example 1 in that the hardest part is going to be to break down the question in order to write the equation. Once you've got the equation, it won't be too bad. Okay, the sum, we're going to add, of the least and greatest of which three consecutive integers. Consecutive means next to. So that would be numbers like n. The next one would be n plus 1. The one after that would be n plus 2, right? 2 bigger than the smallest number. Okay, the sum of the least and the greatest. So we have the smallest of three consecutive numbers, the greatest of three consecutive numbers. We're going to take the n, we're going to take the n plus 2, and since it's a sum, we're going to add them up. Is equals 60. Write an equation. We just wrote an equation and then solve the equation. Okay, so we have 2n plus 2 is 60. 2n is 58. N is 29. Write and solve the equation. We wrote it. We solved it to find the numbers described. It's describing a set of three numbers, so we conclude the three consecutive numbers are n, 29, n plus 1 is that middle one we didn't use, 30, and n plus 2, 29 plus 2 is 31.